Hello, welcome to the course of programming and problem solving using C programming language. This subject is introduced by the university for every branch of engineering. Irrespective of the branch a student belongs to, every student is required to have basic exposure to programming language and the skill of logic development and solving problems in engineering corresponding to that branch. Now, in this course, we'll be going through various aspects of programming language. In syllabus point of view, this subject has 5 units like any other subject. Unit 1 is an introduction to the computer and exposure to various basic aspects of a typical programming language. So we'll go through this unit. Here we'll familiarize ourselves with a quick overview of the evolution of computer systems and computing environment and various computing languages. We'll not deal with how many languages are available, but we'll put all those languages into certain broad categories. And how is a program created? How does a typical C programming structure look like? And what is software development cycle or method? And before writing any program, more important than writing a program is the approach to writing a program, what is called as problem solving technique or approach to development of a solution to a problem. And this can be done in one of the 3 ways: algorithms, flowcharts, and a pseudocode. Now, all the 3 are representative of the approach of the programmer to solve a problem through computer. They are not programs, but they aid in writing effective, efficient, performance-oriented program that will yield the result in much lesser time with much lesser memory occupation. Right? We'll know about these also. We'll develop certain flowcharts and pseudocodes also. Applying the software development method, how it happens. We'll have a brief overview of that. And the second part of this unit is actually our core area, that is getting exposure to various aspects or various constituent components of a programming language, particularly in our syllabus, it is C. So we'll have a brief introduction about C programming language and what are the members of this language that aid us in developing good programs. Further, we'll have discussion about and programs about expressions, evaluations, how do we declare variables, how do we assign values, how do we access them, how do we do that. We'll solve some problems, basic problems as part of the subject. In the second chapter, we'll go a little bit further. Normally, our approach to a problem for solving involves doing many things again and again and doing things based on certain requirements being fulfilled. And these we call in the language or computer language parlance as conditional statements and repetitive or iterative statements. Accordingly, constructs are required in the language. So second unit predominantly focuses on how to write program that does the job repeatedly in much faster and more effective manner without any fatigue. Right? Similarly, control statements are used and then loop statements are used. Different kinds of statements are used. Sometimes it may so happen that if a condition is not satisfied, then the further operation should go to the next part rather than this part. So breaking from the current location and going to the next statement is very essential. And these are called as break statements. On the contrary, it could so happen that you would like to continue the same activity if something is fulfilled or something is failed, and continue statements. These are all part and parcel of any language, programming language. We'll get to know how to use them. The second part of the second unit deals with modular approach to program. Say, let us understand what is this modular approach in terms of a simple day-to-day activity. We want to have food. We divide the process of having food into having a curry, a pickle, a sambar, and each of these are individual modules. Similarly, a bigger problem for its solution can be divided into several independently executing activities, and then the sum total of these independently executing activities is processed to arrive at the final solution. What we mean to say here is that a program can be seen as, or a solution to a problem can be seen as made up of several smaller solutions, and sum total of these smaller solutions or aggregate of these smaller solutions is the actual solution required for the problem. And in computer science parlance, we call this as decomposition into smaller units. So functions are the basic modules, are independently executing, self-sufficient, self-reliant modules are smaller blocks of bigger problem, and the solution from this is taken and processed further to arrive at the solution for the problem, final solution for the problem. So second unit exposes us to the process of identifying independently executable modules and then separate them from the actual process, final process, and these aid in finding solution in a better way. This modularization also increases in reuse, what is called as reuse concept. Say a task is performed again and again. Rather than putting it as a part of the program, what can be done is this part can be separated and declared and defined as a separate function. As and when required, the function services are called, and then once the task is done, the process goes to the next statement after the statement after the function is called here. So reuse is second advantage of modularization. Modularization increases readability of the program. That means suppose something is not working, I am trying to find out what went wrong. I have the advantage of dividing the problem into localizing the problem or identification of local point. From that point of view, I can isolate a small module. I can check module wise and see where exactly the problem is. So modularization, localization of problem, solving the problem in a much simpler manner, and reuse are the advantages of writing a program for a problem. For example, in civil engineering, the stress calculation on a structure is a very repetitive activity. In a bigger program, when a module is written, whenever computations are required, appropriate variables or values are given and the function services are called, the function would perform, give the result, and then the result can be taken for further processing purposes. This is how. So we will also get to know what are the various types of data. That means data has certain life and scope, what are called as life and scope. That means validity of a variable and the scope where it is visible. Validity or life and visibility of a variable in a program is to be known very essentially. The role played by different data variables is different at different points of time. So to address this problem properly, what is called as the story classes are to be learned much better. Sometimes it so happens that the data available has to be changed in its form for usage at that point of time. It doesn't mean that original data form would be changed. For example, I have a real number or a float number, what we call in C programming languages, float number, a real number, an integer part and a fractional part. But in a particular operation, I want only integer value of it. What I can do is rather than changing the value, I can take integer value of it. That means I am locally for that point of at that point of time for that particular specific purposes, I am converting a real number into an integer number. Right? A fractional number is removed, fractional part is removed, and integer part is taken for operational purposes. But original number is not changed, and this is called as type conversion. This is also we will study. Right? These are all. In the third unit, we go to arrays and strings. See, computer is a numerical machine, but the data in our life, in real life, is hardly only confined to numbers. We have our names, our relatives, and various things that are actually not numbers. There should be a facility in a programming language to represent these non-number data items so that they can be processed, they can be evaluated, and certain useful, purposeful tasks can be performed using this non-numerical data. Such non-numerical data are called as character or string variables. For example, our name is a string variable. Our gender in terms of yes or no is a character variable. Right? All such things are there. String manipulation we'll get to know in third chapter. In the fourth chapter, we'll study about pointers. The concept of pointers is very simple to understand actually. Say, I stay in a house and that house has certain address. If the address is given, from the address, I can be traced to the address. So the address becomes pointer to me, it points to me. Rather than taking the data and operating on it directly, sometimes it is very convenient or very handy and effective to use memory locations. Through that memory, the operation is performed on the content of that memory, that is indirect operations. Definitely, concept of pointers increases processing time, but it gives more control to the programmer to control the computer functionality or get the results done in more effective manner. Right? Sometimes what happens, some errors do occur. So what should the computer do when such error occurs? That is an unforeseen condition occurs. For example, we are computing, a program is computing, and in between, what happens is that a division operation is there, and something like x by 0 arrives at, this 0 being calculated. Now, we know that x by 0 is infinity, but how does the computer know? We should make the computer understand that this is not a computable component. So exit from this and safely come out to the state where it was previously in the safest condition. That is last known good function. And such errors being thrown, if unforeseen circumstances occur, errors being thrown is called as error handling in the programming language. These concepts we get to know. Lastly, in the fifth unit, there are derived data types. That means any data type has any programming language has fundamental data types or fundamental units of measuring something. For example, the most fundamental unit of measuring time is second, but we talk in terms of minutes, hours, days, months, years, and so on. These are higher units. Similarly, take the case of distance. The most basic unit is meter. but we talk of kilometers, millions of kilometers, or light years in case of astronomy. All these are higher units. Similarly, in a programming language, basic units are there. Those basic units are insufficient to do higher operations. Then in that case, what happens? Certain derived data items are to be created, or composite data items are to be created, where one unit is actually logically related with several dissimilar types of data items. Let's understand this way. For example, a person, when considered, a person has name, which is a character. A person has age, which is a numerical. A person has a salary, which is a real number. A person has an identity, or what is called as identifier. For example, roll number, or employee ID, or Aadhaar card number. So though these are, we see that each of them belong to different data type, but all of them are connected to one person, and that kind of data person is to be identified with the help of Aadhaar card. Say we give Aadhaar card as input, name of the person, address where is, what is his, other details come out. All these are relevant to a person, but from computer point of view, they are different data types. To operate on such data types, we need to develop higher powerful data, composite data elements, which are called as structures. All of them may be used, any one of them may be used. So fifth unit focuses on this type of derived data structures and certain user-defined data structures. Right? And lastly, in the fifth unit, we talk of concept of file. A file is a collection of data related to a certain activity. And how to access these files, what are the operations that can be performed on these files. So this is in a nutshell the whole syllabus that we will be traveling in the 45 plus classes that we go through this subject. We will be discussing. Now, welcome to the first unit, first part, Introduction to Computer. Fine, we'll get familiar with computer systems. In this part, we'll know about what are the computing environments, what are the basic parts of it, a quick overview, right? These days at school level, computer courses or exposure to computers is given much earlier. So, but we'll have a quick review from our subject point of view. Right. We have covered this part, a quick review. Why learn C? Because we want to make the computer work for our problem in more effective manner without any fatigue. That's why computers are required. Routine jobs to be done by us are to be handed over to computer to process them, and the processed result is taken from the computer for further decision making purposes. Computer is no replacement. So programming lets process, store, present data differently. So what does program do? Program accepts a data from the user, processes it, and gives the result, also stores in a different. So transformation of data takes place from one form to another form. For example, when we write a program for multiplication of two numbers, the input is two numbers and the output is product. So what has happened in the program is that the two inputs are transformed into a product in the computer. Complex calculations in fast, accurate, and precise manner. Now what happens? Suppose I am given a task to perform 100 multiplications. 100 is too small a number as far as engineering problems are concerned or finding solution for engineering is concerned. Take the case of, for example, a construction of multi-story structures. A lot of calculations are involved, not hundreds, they go into thousands, and precision is very high. Maybe to third decimal point, it is required to be done, or sixth decimal point in some cases, probably has to be done. Such calculations, if I am to do manually, soon I will be subjected to fatigue. Tiresomeness. I get tired. And all such repetitive jobs can be given to computer and which will calculate accurately. Accuracy means, is computer more accurate? I am more accurate. Human being more accurate? Definitely I am. But when it comes to doing the same problem 5 times, 10 times, 6 times, 10 times, 20 times, maybe I will commit mistake. Maybe I will not do perfectly. But computer does not have that problem. It keeps doing in the precise manner. Next, most popular programming languages that are useful for civil engineering are AutoCAD, StatPro, Primavera, Revit, ETABS, SAP 2000, MS Excel, and ArcCG. Each of these software packages can do the jobs to some extent in the most generic manner. But a time may come or a need may come in a particular case where what is done by these packages is not sufficient. The engineer, the civil engineer at work is required to write a small piece of program over and above what the package can do. For that purpose, programming language skill is very essential for civil engineers also. Not only that, AutoCAD was developed by a mechanical engineer. StatPro was developed by a civil engineer. Primavera was developed by a civil engineer. Revit was developed by a civil engineer. Now you see, when a civil engineer learns the programming, how to program, he is the best software developer for the need, for meeting the needs of that branch requirements or automation in that branch. So for that point, from that point of view, the highest level, civil engineer becoming a programming engineer, developing packages for the benefit of the civil engineering world and civil engineering community. At the lowest level, use the packages more effectively. Either of these requires logic development using the tools. Software program is a tool at hand. It has long back ceased to be confined only to the computer science domain. Everyone needs programming skill today. So what are the tasks that can be performed? Develop software for handling large data sets. As I said earlier, a multi-story structure or a construction of a public utility service like dam, reservoirs, or infrastructure, road developments. For all these, large, huge numbers of data will be available, and develop a software to handle these large sets of data to arrive at a proper conclusion for the best type of action that can be taken. Automate routing process in profession. We have already covered this point. What computer can do the best to us is do the operations, routine operations perfectly without any mistake. How do you cover the plan? We have already discussed about it. Now, so the journey is something like this. The first unit, computer systems and computing environment, computer languages, pseudocode, flowcharts and algorithms, software development method. We have seen the syllabus. So in this order, we'll be going. There will be a small change. First one, computer systems. What is a computing system? What is a computer? It is an advanced electronic data processing device. See the words carefully. Listen to the words carefully. It is an advanced electronic data processing device. So it is a processing device. Electronic, of course, the word is very clear. It is a data processing device computer is not decision-making device, it is a decision supporting device. For that decision making, it has to process the data. So we say computer is an advanced data processing. Now, what is the meaning of this advanced? Calculator is also data processing. Data bank is also processing. Electronic typewriter is also anything electronic, there is some processing always. But advanced in the sense, it means it can do much higher problems, more complex problems also. It can help us in resolving or finding solutions for more complex problems also. That's why we say advanced. That takes input in one form and gives out in a desired form. The output is generated by manipulating the input data according to a set of instructions called program. How is this data manipulated? We write a program. What is this program? It is a collection of instruction statements one by one to execute. That means a program has an ordered and structured approach, step-by-step activity to process the data and give the output. Both input and output can be given in a particular format. What is this format? We will see. Right? There are various formats in which data can be given. A program is to be developed. Now, what is the meaning of this sentence is that a program is to do with the skill of developing a solution for the problem. When we say skill, it comes by practice. So programming is not at all a problem. Actually easy. In fact, we solve problems at much higher level than program level. Since computer is to execute instruction by instruction, we need to put that solution into instruction by instruction format that the computer can handle it. Computer cannot do higher level works. It can do when it is told. Like it's like a child. Every instruction need to be told. To do that, we have to scale down our IQ levels. We have to tone down. We have to come down to the lower levels of primitive working levels and develop program from that scratch. And this is a skill. We have already traveled a certain distance. To make the computer work for us, we have to come back and bring the computer to that level so that we can focus on more important or more intelligent oriented works. The output can be formatted. We can get the output in the form that we want. Next, for example, as an analogy, let me take a car is a vehicle that is available. A driver is the one who drives the car. Assume that the car is a computer. Driver is a program. Now, who drives it? Driver has a program to run the car in the way it is to run. So, a program is something like components made up of components like clutch, gear, braking system, appropriately using at appropriate times to have the journey in the safest manner possible. So, program is a driver, computer is like a car. And who develops this? We. Now we'll come to parts of a computer. A quick word. As you can see in the diagram, a computer has three parts to it. The input, the processing part, and the output. Of course, there is small block here. What is called as the auxiliary storage devices. Now, we are familiar with this block diagram. Let me have a quick overview of that. Input, standard input device is keyboard. There can be other forms of devices also, but most of the times we will be discussing about keyboard only. Of course, its counterpart, mouse is also there. In most common approach, input is given by keyboard to the computer or through the keyboard to the computer. What we call as CPU. CPU is enabled by, associated by memory to which it has access. That means the input given by the user through the keyboard goes into the primary memory, and from there the CPU accesses it, processes it, and then it saves. You can see the double arrow here, double arrow running between auxiliary memory and this CPU, right? Mostly CPU and RAM put together, or CPU and RAM put together, is called as single CPU or single block in most of the times, though it is shown separately here. And these auxiliary devices are nothing but our hard disks, pen drives, or tape drives, where we want to store the information and access as and when we require it. Why can't we store in the computer itself or in the primary memory itself? Primary memory is a volatile memory which loses its contents when power is gone. Said otherwise, in another way, let us try to understand this way. All of us remember our maths notebook when we are in schooling. Two red lines, one on the left side, second on the right side. Normally, the total area of the page is divided into 50% in between, 25% this side, or 10% this side, and remaining 20% that side. What do we use this three parts, or what for? What are the purpose? What is the purpose served by the three partitions that we have in the maths book? In the left part, we put the math problem number, and in the right part, we do scratch work or rough work. In between, there is the problem, description, working, and the solution stored there. Now, the central part can be compared to the hard disk. As and when we require, we look at that point only and take it. Next, we don't do anything with scratch pad area or rough work area. We don't need it unless we get doubt in the hard disk. We don't go to unless we get into the doubt in the working part that we have. We don't go to the rough work area. RAM or primary memory is similar to the rough work in the maths textbook, maths notebook. I'm sorry, it's maths notebook. And come to the left part now. In the left part, we are writing the address of the problem, and this address will be available in the hard disk only. So left part and middle part are stored in the hard disk. When we access with the help of address, the problem is taken. But this difference between maths notebook and computer is that in maths notebook, whatever we have scribbled in the rough area is always available unless we erase it. Here, it gets erased. So primary memory does not have permanent storage. Right? Now, and where does this output go to? Alternatively, while it is stored, the output will go to standard output devices, monitor and printer. Printout is an optional aspect. Monitor is the default device. There is another version of this block diagram. Let's see it. Internal structure point of view. I was telling you, right? This entire thing, you can see here that the entire outer block put together is called as CPU, right? This memory unit is primary memory and arithmetic and logic unit. Why is it called as arithmetic logic unit? This is the core part of the processor which actually does computations, and the computations include arithmetic operations and logical operations. And these operations, as well as memory, and the way input is taken, the way output is given, is controlled by the brain-like device called control unit. You can see that from control unit, arrow is running to every block here. So there will be continuous flow. Under the control unit, again, how does the control unit control it? It's again a program written at the lower level or the machine level. So everything is a program, structured program. That means there are two types of programs. One set of program is used for computer by itself to facilitate the task to be done for the user. Second set is user level programs. So this is how we understand the parts of a computer. Now, what is a computing environment? You can see here from the diagram. Starting from the top, we have personal computing environment. That means there is a standalone computer, single user, and the single user uses all his resources, and he is the sole owner of the data and the processing and the result of the computer. It is not shared. It is for single purposes, right? For example, small offices with single computer are an example of this type. Or SOHO, small office and home office. That means almost computer is essential asset in every house today, almost, right? The second one is time sharing computing environment. The speed of the computer is exploited so that in batches, in different time slots, different users programs may be executed. Time slots are provided, and for effective utilization of the computing resources, time sharing applications are there. Scheduling is there. Client server computing environment. Now, in case of time sharing environment, what happens is that normally the user interface is with minimal electronic circuitry and no processing takes place. The data and instruction given by the user from the keyboard is taken to the server, central server, where the processing takes place. That means the user's interface is passive element. The only job it does is transfer the instructions and data to the central location, and task is performed. Now, what happens? What is the problem here is that the system could get drastically slow because everything is in central location and several users are using, and the response may get slower. But there are certain applications which can be done on local system. That means rather than dumb terminal, the system at the local level in a network environment can be intelligent, running local programs here only using the network environment for the appropriate essential processing purposes, probably central data storing purposes. Such system is called as client server system. In the client server system, there is a network, and there is a central server. Central service server has its own service to give. For example, it could be a server for communication purposes, centralized communication purposes, where clients will be using, or it could be a fax service, or it could be internet service, or it could be communication service, or it could be file service. Centralized file is every user stores data in a central location. Or it could be high power computer. The computing resources, the computing power of the processor is shared by all the users. So there are various types. Right? Now, here the client knows where the data pertaining to the client is being transmitted to, processed, and getting back. This is client server environment or network environment. As opposed to it, the client does not know where the client's data is being processed. That means it is transparent to the client. What does the client do here is, it sends its request for service to the server. But the server may be serving, or some other server may be serving, or some other device may be doing the activity. It is transparent to the client here. This kind of environment is called as distributed environment. This is another environment. Take, for example, internet. Suppose I am downloading a software from Microsoft website. I am not sure whether the software is being downloaded from US server or Singapore server or Australia server. There are servers replicated in various locations, and these are internally connected. So, though I have visited US website, Microsoft.com, when I download something from Microsoft website, in fact, all the service without my knowledge probably is being given by Australia server, which are called as proxies, or Singapore, or Malaysia, or Hong Kong, some location which is nearest to my geographical location. What the data transmission takes place more effectively, line errors or line related errors may not be a problem, to ensure that quick services are given here. The next one, cloud computing environment. Again, in distributed environment or client server environment, the data is stored here. Cloud is a technology where the data or service or the programs are to be used on a rental basis, and as and when we need, services are utilized. For example, I need to work on Oracle database or Oracle program for data processing purposes. I don't want to spend money on purchasing costly Oracle software. Some service provider who has purchased high power computing environment calls it a cloud, and I can take services from that cloud by paying service charges only, charges for the service taken only. It's something like that. I don't want to construct my house, so I can stay in a rented house. I don't cook in my food. I go to a hotel. I don't give entire money for total hotel construction. I use only for service purposes only that I have taken. This concept is called as cloud, a shared resources for various activities, so that I need to spend only that much I have to spend. I ought to spend. So effective utilization of resources. And above this, cluster computing environment is the highest level where clusters of computers are available. For example, when you take a, a multinational company which has representation in 70 countries like Microsoft, or mobile services company like Oppo, which has outlets in several countries, not outlets, manufacturing units in several countries. These they themselves are huge networks, and this collection of networks is called as cluster computing environment. Now, under this environment, this kind of environment, now why should I know as a civil engineer? Am I required to know all this? Yes, very much. I need to have at least basic knowledge about this. Maybe tomorrow my company says, I don't want to invest on computers, get the cloud services. So as a civil engineer, I should know what kind of packages are, what kind of services are there in the cloud and how to use them. So I have to have basic exposure to them. So this is what we discussed so far. So what is a computing environment? To synopsize, a computing environment is a collection of computer and machinery, as we can see here, data storage devices, as we can see here also, and workstations. When I said client server, there will be workstations. Software applications, I said centralized software which can compute much higher, which has high computing power. For example, in artificial intelligence or machine learning networks, there are GPU processors with high-end software. These are all software applications. And networks that support the processing and exchange of electronic information demanded by the software solution. So this is what is about computing environment. Now we'll go to the next one, computer software. As I said, we'll not have a discussion of what is software, what is, and so on. We put them into broad categories of software. We'll get just familiarity about it. Software that is used in the computer can be put broadly divided into system software and application software, as you can see from the classification diagram that we have here. System software and application software. System software is again available in 3 flavors. Operating system, as I said earlier, certain part of this software is given responsibility to the computer itself. It will manage itself, it will monitor itself, it uses software for its own control and facilitation purposes. Operating system. Next, system support software is another one. The third one is system development software. What are these? We will see in a way. So, and the application side, a general purpose and application specific. General purpose, for example, Word, Windows Word, Microsoft Word is a general purpose which is used for creating any type of document. A lawyer may use, a doctor may use, a chartered accountant may use. They are called as general purpose. On the other hand, application specific softwares are specifically used for certain purposes. For example, invoices generated by a company, purchase orders generated by a company, or application specific softwares. We'll have a brief discussion about them. What is it? System software manages computer resources. Predominantly, system software is developed for use by the system for the system. So it is for managing of the resources of the computer. It is an interface between hardware and users. When user gives instructions, and this instruction or command given by the user is taken up by the system software to convert it into machine understandable instructions, executed, get the result, and transfer it back to the user in the form user understands. So they work as interface between hardware and users. There are three types, as we said. Application software. What does application software do? Helps the user solve the problem, as I said, a generic or a specific purpose. So these are the types of software, a general purpose and application software. Now, coming to computer languages now. So how are we traveling? We had exposure about what is a computer, what is an environment, and where does the language fit here. When we said system software, application software, we are talking of the programs here. And these programs fall into different categories again. So what are the categories? We will see it here. Machine level language. A machine level language is the language that is understood by the machine. Now what is a machine here? Computer. What is a computer? We said it is high performance electronic device, computational device or data processing device. And anything electronical is actually electrical. Electrical means electrical signals are there. Since this is digital device, the signals are given in terms of zeros and ones. So machine language is actually a chain of zeros and ones in a particular pattern that is given to the computer for processing purposes. How to process is given by the control software. We already had this small discussion about it, right? It's a sequence of zeros and ones divided into blocks of code, and this particular code is called as American Standard Code for Information Interchange. And this code is developed by the software companies and the US government put together to standardize the processing of the computer across the globe. There are two popular codes that are developed, ASCII and EBCDIC, right? ASCII is the most popular code in the world. And what we say, blocks of zeros and ones. Now we said to the computer, everything is number only. My name is also a number. Alphabet A is also a number, which means that we have to put a coding system where everything that we use for computational purposes is converted into a standard code. That standardized code is called as ASCII. And we have also put in a standard format blocks. For example, A to Z will have a block of codes incrementing by one by one. For example, in ASCII, the numerical value of alphabet capital A is 65 in decimal. Logically, since computer is a logical machine, we should make it use the logic very simply, effectively. B should be 66, C should be 67, and up till like that. Similarly, 0 through 9 are given certain code. certain range. Every character that we use on our keyboard is given certain code, and this is called as block. And machine language understands only in terms of zeros and ones. It's something like, suppose I want the computer to work for me, I should know its language. That means I should start giving instructions in machine language. It is something like this. The other person knows Chinese, I have to learn Chinese to teach. The other person knows Japanese, I have to learn Japanese to talk with that person. And you see that it's a most laborious work. Writing a program, converting each alphabet into the ASCII code and giving instructions one by one on our own is the most time consuming. We have long back, we have driven away ourselves or traveled in the process of technology development from that machine level to highest level, our user level programs. So the second level of programs that we have are symbolic languages, or symbols or mnemonics. What is done here is mnemonics called, that means cryptic English like words are generated, created, meanings are also given, and these meanings are interpreted to represent some operation to be performed in the computer. Recollect that Bahubali movie where Kalakeya speaks certain peculiar language, mnemonics, right? They have their own meaning. Similarly, computer, instead of writing machine languages, we have developed in mnemonics. That means, for example, add is a mnemonic. What does it do? When we say add, it is expected that two numbers are to be given for addition purposes. And where to store the result? It could be another memory, or one of the same memories can be used as updation purposes. This is called as cryptic language. So mnemonics are used, or codes are used, and they more look like English words only, but they are not complete words. Right? Symbolic language. And symbolic languages are not for the machine. Machine has zeros and ones only. Symbolic language is an intermediary developed so that my pain is reduced, or my stress or my painstaking job is absorbed by mnemonics so that I can write in mnemonics. And next level, mnemonic is to be converted into zeros and ones chains for instruction purposes. So they are special Unicode for each operation. They are developed as a special unique code for each operation. As I said, add, sub, mul, div, or the div for divide, JMP, jump, bun, branch unconditionally, BR, branch. All these are mnemonics. So map each code to a specific machine language code, and this is done by assembler. So what does an assembler do is, when we write a mnemonic based program for our problem, remember our job is 25% effort, 25 to 30% pain is reduced, because assembler is taking the responsibility of converting the mnemonic based program to machine level language. Assemblers are the ones, special purpose programs that help us in developing mnemonics based program, and they take the responsibility of converting into machine language. We don't require, as civil engineers, we don't require. And these symbolic languages are machine dependent. What do you mean by that? There are various computer manufacturers with different processor architectures and address systems and their own way of processing the data. Intel based computers like the computers that are developed as Lenovo, Dell, all these computers, they are called as IBM compatible computers. They have one set of mnemonics. On the other hand, Macintosh computer, Mac, has its own symbolic language. Motorola has its own symbolic language. Why this? Why do we say it is machine dependent? Because each code is uniquely developed and it is mapped onto one particular instruction. So the way it is written is differing. So it becomes machine dependent. High level languages, they let the programmers focus on the solution. So there are more English, like more user level friendly languages. Small statements are given, chain of statements are given, and then in between assembler comes, takes this program, assembler converts it into mnemonics, and then assembler again converts it into machine level language. And greatest advantage of the high level language programs is that they are machine independent. I can write, it means that I can write a C program on my Dell computer and take the source program and go to another machine, which is a Mac computer, and it gets compiled there for that environment. So this is called as portability feature. So high level languages make the solution for a problem platform independent. It can be used on any computer. So they are portable. So this is our first session. We'll stop here and take up another topic in the next class.